I'd like to do a quick review for some of you today on ordered pairs, functions, graphing planes. This will be brief and I hope you'll find it helpful. First of all, I just want to remind you of a couple of key things here. The first thing to remember is that an ordered pair is a set of two numbers in parentheses. This ordered pair is 2, 3. This one's 0, 1. X is represented in the first number. Y is represented in the second number. Another key term is relation. And a relation is just a set of ordered pairs. So you just have a group of ordered pairs that you are going to do something with. And that's called a relation. The X is that first number. It's, if you're thinking of like an input-output box that you've used for years and years and years, the X is the input and it's considered the domain. And the Y is the output and it's considered the range. Now, a function is a very special relation in which each input has exactly one output. So that means for the X, there's only one unique Y. So this could be a function because the X goes to a 3 and the X goes to a 1. But if I added up here another 1 and I said 2, 4, then that would no longer be a function because the input is going to two different numbers. So it's no longer a function. The function has to have a unique X in the entire set of values. So when we look at a coordinate plane, and I haven't filled it in because I just want to do a couple of things in it real quick. I want to just show you again, the X-axis is the horizontal line and the Y-axis is the vertical line. And I usually mentally try to remember that by knowing that the Y-axis goes up and you can have a Y at the top. So it would look like a Y. You could kind of see that. That's how I've always remembered in case I get confused. The X is the horizontal. The Y is the vertical because it takes a vertical look to make a Y. The origin is where the X and the Y intersect. It is right here at point 0, 0. And a linear function is when you have a set of points that lie on a straight line. I can have lots of different points, but if my points create a straight line, well, that one is supposed to be straight, that would be a linear function, as opposed to my points that might look like this and when connected would not be linear. So that's what I just want to make sure you understand. It is what it sounds like. Linear function must create a straight line. So on this last one that I have up here upside down, I have kind of an input-output box, and then I have a graph. And I know what my X is, so if I plug my X in, I used to always tell my class, plug it in, just like the air freshener, just to remember what you're doing. So if I have a 2 for my X, my equation up here says that I should multiply it by 2 and subtract 1. So if I put it in the input box, I have 2 times 2 is 4, take away 1 is 3. So when X is 2, Y is 3. If X is 3, 2 times 3 is 6, take away 1, 5. If X is 4, 2 times 4 is 8, take away 1, 7. And so on. 2 times 5, take away 1 is 9. That becomes my completed graphing box there. And I want to go ahead and do this other one. They're just, you could have any kind of equation up there. If X is 20, you take away 5, my Y becomes 15. If X is 18, take away 5, 13. If x is 10, take away 5, it's 5. X is 5, take away 5, it's 0. Now I could come out here, and once we have this, these become my ordered pairs. 2, 3, 3, 5, 4, 7, 5, 9. And then I could come over here and graph this. This is not a perfect graph, or a plane. So this means go over 2, up 3. You always walk before you fly. You stride before you ride. You walk before you run. Whatever little saying you can remember. You always go horizontally before you move vertically. X horizontally, Y vertical. So I'll go over 2, 1, 2, and up 3, and I have my point. Over 3, up 5, I have my point. Over 4, oh, I did that one a little too close. Over 3, up 4, over 4, up to 7, over 5, up to 9. So that's what that would look like. This one would have the appearance of x is 20, so I'm going to go over 20 and up to 15. It would kind of be right here because here's my 15. Over and then up, over, up. So over 18, up 15. I'm going to have to be right in the middle. I mean, over, that's a 13. Over 13. Over 10, up 5. Over 5, up 0. So I'm not moving at all. So that's what that looks like. Those are your plotted points. If this were a perfect graph, you know, you'd have your line straight through and you'd know whether or not these were linear or not. But I just wanted you to see that just as a brief review.